On the night of November 28th, when most professional observatories were busy with scheduled calibrations and deep sky tracking, the earliest hints of something extraordinary did not appear on the screens of NASA's control rooms, nor in the silent domes of the Atacama Desert. Instead, the first warnings pulsed from cheap consumer weather stations, perched on the balconies of apartment towers in Shanghai, from air quality monitors strapped to lampposts in Sao Paulo, and from amateur radio receivers humming near high-rise blocks in Munich. It began as a tremor in data streams, a stutter in the telemetry that should have been uniform, predictable, and unremarkable. But the irregularities favored only one environment: cities. Not towns, not rural plains, not sparsely populated coastlines. Only regions saturated with human machinery, clustered electronics, and dense electromagnetic activity. And as dawn approached across multiple continents, analysts reviewing the anomalies began to realize that the object known as 3I Atlas had behaved differently depending on where the sensors were located, as if the comet had looked through Earth's own technological map and reacted only to the brightest points on it. At first, the phenomenon appeared statistical, a coincidence formed by pollution, temperature gradients, or human interference. But within hours, the pattern hardened into something impossible to dismiss. Every large metropolitan zone within the comet's visibility experienced synchronous data drift, oscillating noise bands in magnetometers, micro-interruptions in GPS lock, unexplained amplitude dips in atmospheric sensors, and in some cases, a faint, rhythmic fluctuation in Wi-Fi spectrum density. Meanwhile, identical rural devices, those operating under the same standards, same hardware, same firmware, reported nothing. Not a flicker. It was as though 3I Atlas could distinguish between environments where human presence saturated the air with signals and those where silence still ruled. The anomaly was subtle, elegant, almost deliberate, like a hand brushing across the surface of Earth's technological skin, tracing the cities while ignoring the quiet spaces between them. The first professional team to notice the trend was a joint group at the European Space Agency, reviewing anomalies pulled from environmental satellites. They were expecting routine background noise from an object shedding volatiles as it crossed the solar system, but instead, the logs revealed an alarming asymmetry. Whenever Atlas lined up over a megacity, London, Istanbul, Seoul, the electromagnetic noise floor shifted. It wasn't powerful enough to disrupt infrastructure, not even close, but it altered itself just enough to be noticed, to be measurable. It was as if the object wasn't emitting blindly. It was responding to density, to complexity, to patterns only found where humans gather in massive numbers. Meanwhile, villages, deserts, mountain regions, and islands reported no deviation from baseline. The comet behaved as though the Earth beneath it had two layers, one alive with signals, one dormant. This realization triggered an internal alert at NASA's Goddard Space Flight Center. Analysts there cross-referenced the anomalies with energy consumption maps, cellular tower grids, and the distribution of urban RF pollution. A chilling symmetry emerged. The places where Atlas's effects were strongest were the same places where humanity's electronic footprint was most intense. The correlation was too precise, too selective to be natural. Comets do not prefer cities. Interstellar debris does not listen to human technology. Yet 3I Atlas seemed to do exactly that, altering its behavior according to the concentration of machines below. No model of sublimation, charging, or ion tail deflection could explain it. Something about the object reacted specifically to human clustering, almost like curiosity, almost like attention. By late morning, the anomaly gained a new layer of strangeness. Amateur astronomers living in dense urban zones began reporting that their consumer telescopes were producing faint waveform interference when pointed at Atlas. The signal was too coherent, too structured to be noise. Some described it as a heartbeat hidden in static. Others called it a whisper in the visual spectrum. But none of them could reproduce the phenomenon outside city limits. When those same astronomers carried their equipment to the suburbs, the interference vanished completely. The comet's effect was locked to humanity's technological lattice, to the pulse of electricity, signals, traffic, and machinery that defines a modern city. Rural silence severed the connection. This was the first moment when the scientific community realized something profound. 3i Atlas behaved differently depending on how many humans and how much human technology were beneath its arc. Not gravitational mass, not magnetic latitude, not atmospheric density. Human presence, human activity, human noise. And that was only the beginning. By the time the urban response anomaly of 3i Atlas had spread through internal scientific channels, another pattern began to surface. One far stranger, far more political, and infinitely harder to explain. It started with a quiet report from ESA's satellite division, a simple 2-paragraph anomaly note written by an engineer who assumed it was nothing more than a malfunction in a European weather satellite. The report mentioned that a faint reflected impulse, an ultra-narrowband echo originating from the direction of Atlan, had been detected on a channel normally used for deep space calibration. The signal wasn't strong, not structured enough to be considered communication, yet too organized to be atmospheric noise. The engineer flagged it as an unusual but likely irrelevant return. That assumption lasted less than 6 hours. Because almost immediately after ESA logged their unknown echo, Japan's Himawari 9 weather satellite reported the exact same anomaly, at the exact same frequency spread, with the exact same timing characteristics. Then, a South Korean military communications satellite flagged an identical return. And then, nothing. Dozens of other satellites operating with nearly identical hardware, similar frequency bands, and similar orbital positions were completely unaffected. No echo, no reflection, no anomaly at all. The object in space was acting selectively. It was reflecting a narrow electromagnetic beam only off certain satellites belonging to specific nations, and avoiding others with what appeared to be deliberate precision. At first, engineers assumed the discrepancy was rooted in hardware differences. Different dish sizes, different transponder materials, different shielding compositions. But when analysts filtered through the results, the pattern became too sharp, too unnatural to ignore. Atlas did not reflect off older American satellites. It did not reflect off low-cost commercial platforms. It did not reflect off European military satellites operating in hardened frequency ranges. Instead, the comet's beam selected an extremely specific category: satellites whose transponder arrays used a narrow subset of nickel-coated waveguides, a manufacturing standard shared ironically not by allies, but by Japan, South Korea, India, and parts of ESA's civilian fleet. The alignment was surgical, as if the comet recognized a material signature, not a country, not a purpose, but a specific technological fingerprint. When this discovery reached NASA's Anomaly Review Board, confusion turned to unease. If Atlas's emissions were merely passive, scattered sunlight, thermal noise, or ion tail reflections, then the return pattern would have been random. Instead, it behaved like a scanning system, performing selective handshake tests across Earth's orbital infrastructure. It looked less like physics and more like protocol. Things escalated when the United States Space Force released internal telemetry showing that several of their own reconnaissance satellites passed directly through the comet's reflective beam, yet captured absolutely nothing. It was as if they were invisible to Atlas. Meanwhile, a small Indian weather satellite, a platform considered technologically modest, registered multiple reflections with perfect clarity. Even more unsettling was that the reflections returned only when the satellite faced Earth, never when its antenna array pointed toward deep space. It wasn't simply reflecting to space, it was targeting Earth-facing hardware. A directional decision, a choice. Countries began to notice the implications. Atlas was creating an uneven map of information, feeding data to some nations, accidentally or intentionally, while ignoring others. International labs scrambled to analyze the structural materials of the affected satellites, trying to deduce what made them visible to the comet. But as the cross-indexing expanded, a darker pattern emerged. The satellites receiving the returns were those with open-source architecture, whose calibration data was publicly documented, whose frequency standards were easily readable, predictable, transparent. The satellites that received nothing were the ones whose parameters were classified, encrypted, or deliberately obfuscated. This pushed the scientific community toward a deeply uncomfortable conclusion. 3I Atlas was not just detecting hardware, it was detecting legibility. It responded only to systems that were readable. In other words, Atlas interacted not with nations, but with transparency. Several labs ran simulations theorizing that Atlas's beam behaved similarly to LiDAR, but with a selectivity based on signal coherence and expected reflection behavior. When a satellite's architecture matched predictable resonance patterns, Atlas returned the impulse, almost like a handshake. When it didn't, the beam passed through without interaction. But even that explanation felt incomplete, because the timing of the impulses was not random. The returns arrived at intervals correlated not with orbital positions or sunlight angles, but with moments when the selected satellites were transmitting the heaviest data loads to Earth. As if Atlas wanted to hear not only from the satellite itself, but from the planet it was listening to. This changed the narrative completely. Atlas was not only interacting with satellites, it was choosing which versions of Earth it heard, and the world had no idea why. On the night of November 28th, only a few hours after global observatories finished analyzing the strange dual behavior readings between megacities and rural zones, a new anomaly emerged. And this time, it didn't come from telescopes, cameras, or photometric equipment. It came from the very fabric of Earth's radio environment. At 1:42 UTC, 3 independent amateur radio operators, one in Poland, one in Arizona, one on the outskirts of Osaka, reported the same impossible phenomenon. They were calibrating their systems, sweeping through HF and VHF bands looking for routine atmospheric reflections when the static suddenly collapsed into perfect silence. Not interference, not jamming, but an engineered quiet, a vacuum in the spectrum. And then, with the same unnerving smoothness seen in earlier Atlas anomalies, a returning signal rose from that silence, carrying fragments of their own previous broadcasts, but rearranged with mathematical clarity far beyond the noise of normal ionospheric scatter. It sounded like a correction, like a reply written in their own handwriting, but with grammar they couldn't have produced. At first they thought it was a prank. Pirate stations sometimes bounce altered signals through the ionosphere to confuse hobbyists. But within 6 minutes, NASA's Deep Space Communications Array in Canberra flagged something that forced the internal alert system to escalate. A faint echo had returned along the exact frequency of the DSN's earlier calibration ping, aimed near the Atlas trajectory. And that echo matched no known signature of atmospheric bounce, lunar reflection, plasma scattering, or solar interference. Instead of distortion, the signal came back cleaner than the outgoing wave. The noise floor was reduced by nearly 60%. Phase jitter was corrected. Even the harmonic artifacts present in the DSN transmitter, flaws baked into the system itself, had been removed. The returning waveform resembled what would happen if a machine intercepted the signal, analyzed it, reconstructed the intended structure, and returned an optimized version. Something not just reflecting, but understanding. As more stations turned their arrays toward the comet's location, the pattern became unavoidable. Every outgoing broadcast, even weak, unencoded, low-power emissions, produced a faint but structured echo minutes later, a line from the direction of Atlas. It was as if the object recorded everything it intercepted, processed it, and sent it back through a filter of impossible precision. Norwegian researchers discovered that even civilian FM stations received faint mirror broadcasts containing clean versions of their own audio, arriving with exact delays that matched the round-trip light time between Earth and Atlas. The echoes lacked commercials, lacked compression artifacts, lacked atmospheric hiss. The music returned in perfect equalization, voices returned without distortion, and speech appeared subtly smooth, as if an unseen system had parsed language itself and removed everything it identified as redundant. By dawn, The global scientific community realized this wasn't merely reflection. This was interpretation. Atlas behaved like a relay, but a relay that rewrites what it hears. More unsettling was the pattern hidden inside the corrections. The clean signals shared the same spectral signature that Atlas had previously used in its infrared pulses. That meant the object wasn't just repeating information, it was imposing its own structural logic onto the data, as though attempting to convert human broadcasts into its internal communication format. The waveform spacings matched earlier thermal pulses, forming a repeating cadence embedded within the return signals. The implication was chilling. Atlas appeared to be teaching Earth the rhythm of its language. But the strangest discovery came from MIT's radio astronomy group at Haystack Observatory. They isolated the echo from a standard test transmission, a 30-second pure tone sweep, and ran a Fourier analysis. Embedded within the return tone, beneath the main harmonics, were faint modulations that did not correspond to any known artifact generated by human hardware. The pattern resembled a checksum, a verification structure used in digital communication systems to confirm the integrity of transmitted data. Atlas wasn't just responding, it was confirming receipt. As the hours passed, one final detail emerged, a detail that could not be ignored. The echo always returned with less noise than the original. No natural object in the history of astronomy has ever improved a signal. Reflection always degrades information, but Atlas did the opposite. It returned cleaner than it received. That single fact forced NASA and ESA to reclassify the anomaly from atmospheric to non-terrestrial origin. And suddenly, every scientist on Earth was asking the same silent question. If Atlas can hear us, understand us, correct us, and reply in our own signals, then what exactly is listening out there, in the dark? It took the scientific team several days to fully acknowledge what the amateur radio community had been whispering about long before NASA even issued its first internal bulletin. The phenomenon started silently, almost imperceptibly, as if 3i Atlas was testing humanity's attention rather than openly announcing its next anomaly. A handful of hobbyists across Europe reported unusual clarity in shortwave radio channels. Static that had been normal for decades suddenly vanished. A distorted broadcast from a station in South America came through clean, sharper than ever, only for listeners to realize that the station itself had not improved its equipment. The source of the clarity wasn't on Earth. It was being bounced back from somewhere in deep space, from the direction of Atlas. And when operators replayed the recordings, comparing the original noise to the returned echo, they saw something that should have been impossible. The return signal wasn't identical. It was enhanced, reorganized, and stripped of random fluctuations, as if a massive, distant filter had captured the transmission, analyzed its defects, and sent back a refined version, almost like a diagnostic correction. At first, these events were dismissed as atmospheric ducting, auroral bending, or ionospheric inversion effects. But then came the recordings from Australia, South Korea, Argentina, and rural Texas, hundreds of kilometers apart, using completely different hardware, yet showing the exact same spectral fingerprint in the returned echo. Frequency bands that normally degrade in the noisy environment near megacities suddenly came back, cleaned, sorted, mathematically corrected. Random chatter from police radios, fragments of pop music, moments of sports commentary, emergency broadcasts, all of it continued to echo back, reassembled in a strangely coherent way. The returned waves were not simple reflections. They were structured. All noise removed, all irregularities flattened, all disruptions rewritten into symmetrical patterns that resembled engineered signatures rather than natural scatter. In some transmissions, even the rhythm of speech had been subtly adjusted, as if Atlas had attempted to impose its own sense of order on human communication. The deeper scientists dove into the anomaly, the more unsettling the implications became. Radio astronomers noticed that the return signals carried a faint modulation layer that did not exist in the originals. It wasn't a message in the human sense, but it wasn't meaningless either. It was a systematic pattern, recurring harmonics, consistent intervals, a kind of mathematical watermark riding beneath the corrected broadcasts. The watermark was present in every altered echo regardless of origin. Whether it was a music station in Berlin or a weather report from Tokyo, the pattern remained stable. That stability implied a single processing node, a single origin, a single system analyzing, modifying, and returning Earth's radio waves with precision that couldn't be explained by natural reflection from dust, ice, or a comet's plasma tail. What truly pushed the scientific community into shock wasn't the existence of the phenomenon, but its selectivity. Atlas didn't reflect everything. It returned only transmissions that had a certain density of human structure, ordered speech, rhythm, information-rich layering. Empty carrier waves were ignored. Static noise was ignored. Pure tones were ignored. But whenever a signal contained human patterning, especially language, the returned echo became stronger, cleaner, more detailed. Almost as if Atlas understood the difference between noise and meaning. Some researchers began suggesting that the object was using the incoming transmissions as raw data, studying patterns of structure, organization, syntax. Others went further, proposing that the return signals were not improvements but tests, attempts to see how humans would react when our own information came back to us, altered by a foreign intelligence. The strangest moment came when a team in Italy transmitted a deliberately chaotic mixture of noise, scrambled speech fragments, and reversed audio toward the region of space where Atlas was traveling. The returned echo, which arrived 2 minutes later, contained none of the chaos. Instead, it came back sorted into frequency bands, reorganized into smooth, ascending harmonic sequences, as if the object had attempted to repair what it interpreted as a damaged message. This was the moment when the leading radiophysicist on the project stated openly, "It doesn't simply reflect, it interprets." And once that conclusion was on paper, everything changed. Because whatever interprets does not behave like a comet, a dust cloud, or a frozen interstellar rock drifting silently through space. It behaves like a listener. The first indication that something was fundamentally wrong came not from astronomers, but from satellite engineers inside 3 different national space agencies who, by coincidence, were all reviewing routine diagnostics at nearly the same hour. What they initially saw looked like a simple telemetry glitch, a brief misalignment spike in their satellite's reflective signature data, the kind that usually appears during geomagnetic turbulence. But when they overlaid those disturbances on sky maps, their stomachs dropped. Every anomaly pointed to the same direction in space. Every spike carried the same angular deviation. And worst of all, every affected satellite belonged to the same cluster of hardware standards, a specific generation of mid-frequency transponders manufactured between 2011 and 2017. Out of hundreds of satellites orbiting Earth, only 19 showed the reflection anomaly. All 19 shared the same modulation structure, the same operating temperature range, and the same digitally stabilized antenna platform. Satellites outside that design family remained silent and untouched, as if Atlas simply didn't see them, or worse, saw them and chose to ignore them. Global agencies tried to brush it off as coincidence, until engineers noticed a pattern far too deliberate to dismiss. The reflective beam, a faint, low-energy pulse emerging from the trailing edge of 3i Atlas, bounced only from satellites that used a specific error correction protocol. Not higher quality, not newer, not strategically deployed, simply the ones built with that precise algorithmic architecture. When agencies tried to replicate the anomaly with ground transmitters, nothing happened. When they tested older satellites from the same countries, nothing happened. But as soon as a satellite inside that narrow hardware window crossed the beam's trajectory again, the reflection reappeared with perfect precision, like a lock responding only to a specific key. It was as if Atlas wasn't scanning Earth randomly, but conducting a compatibility test, filtering through our planet's orbital shell and only responding to devices that matched whatever internal criteria the object recognized. Scientists quickly realized this wasn't about geography, politics, or ownership. American satellites were affected. So were Indian, Japanese, Korean, and one from the European Space Agency. Meanwhile, many US military satellites receiving far stronger signals were completely ignored. China's entire constellation remained untouched. Russia's, untouched. It had nothing to do with nations. It had everything to do with architecture, a precise technological lineage that Atlas singled out with unnerving consistency. And when analysts looked deeper, they found an even stranger detail. The reflective intensity was strongest on satellites whose transponders were slightly degraded from age. These weren't the pristine modern machines. They were older, with imperfect calibration, predictable drift, and consistent packet loss. And Atlas reflected from them more clearly than from any others. One theory began to spread among internal scientific circles, quietly whispered first, then documented in encrypted memos. Perhaps Atlas prefers predictable imperfections. Newer machines self-correct too efficiently, masking their internal signatures. Less advanced satellites reveal more raw data, clearer timing noise, cleaner thermal drift, more stable systemic flaws. If a foreign system were trying to evaluate the technological development level of a civilization, these imperfect machines would be ideal samples. That would explain why Atlas didn't simply bounce signals off every satellite it encountered, but instead chose very specific ones. It wasn't communicating, it was calibrating. The reflection events grew stranger with each passing orbit. The beam didn't hit the satellites directly, but brushed across them, as though Atlas calculated their exact reflective properties in advance. There were no random scatter patterns, no chaotic returns. The reflected pulses carried symmetrical intervals, like Atlas was mapping not position, but internal function. Some satellites recorded minor torque adjustments at the moment of contact. Nothing dangerous, just enough to indicate an external influence aligning with their structural frequency. The idea that a comet could resonate with hardware built on Earth would have been laughable weeks earlier. Now it was treated as an emerging classification, precision-targeted resonance interaction. It wasn't until analysts replayed the reflection timing that the full scale of the anomaly became clear. The reflected pulses didn't just mirror satellite motion, they predicted it. Atlas returned pulses fractionally ahead of the satellite's rotation cycles, compensating for mechanical lag with microsecond accuracy. Because it knew their rhythm, it knew their drift, it knew their aging transponders down to their predictable errors. And that meant something far more profound than selective reflection. It meant Atlas had been listening to our orbital shell long enough to build internal models of each qualifying satellite. Not their countries, not their purpose, but their physics. For the scientists observing the pattern, one realization rose above all others. Atlas wasn't choosing satellites based on intelligence gathering value. It was choosing them based on interoperability. It was selecting devices that matched its own structural logic, as if searching for compatible nodes in a network, not to send messages, but to test resonance, synchronization, and responsiveness. Someone in an internal ESA thread wrote the sentence that quickly circulated through every secure channel. It is not contacting nations. It is contacting machines. And once that thought surfaced, the world's understanding of Atlas shifted again. Because if it chooses our technology based on shared structure, then it means one thing we are not ready to say out loud. It recognizes something familiar. From the moment the data began to converge from solar observatories around the world, it became clear that 3i Atlas was no longer behaving like an isolated traveler drifting through the solar system, but more like a system that had linked itself to something far larger and more fundamental. Solar physicists first noticed the pattern when they overlaid the object's recurring brightness pulses with helioseismic rotation charts. The alignment seemed accidental at first, small fluctuations in Atlas's luminosity coinciding with the rotational bands of our star. But as days passed and more readings accumulated, the synchronization became too precise to ignore. Atlas wasn't merely echoing the sun, it was anticipating it. Each pulse from the object occurred just slightly ahead of the matching feature on the solar surface, as though Atlas was predicting where the next shift in magnetic topology would occur before it actually happened. This was not coincidence, not a quirk of measurement, not the result of flawed calibration. It was an empirical pattern repeating with such fidelity that even the most conservative solar researchers began to reconsider what they were observing. The phenomenon deepened when ESA's solar dynamics cluster detected an unusual coherence between the timing of Atlas's ion tail modulations and the torsional oscillations beneath the sun's photosphere. These oscillations are subtle, internal flows of plasma that even our most advanced instruments barely detect. Yet Atlas's outflow seemed to pulse in rhythm with them, as if the object possessed an understanding of the star's internal dynamics on a level humanity has never achieved. And what made the anomaly even more unsettling was that Atlas appeared to lead the sun by measurable intervals, consistently releasing its pulses seconds to minutes before an equivalent fluctuation occurred within the solar surface layers. It was not reacting, it was pre-echoing. This forced physicists to consider a possibility nearly unthinkable, that Atlas might be reading the sun, either by sensing its deep magnetohydrodynamic structures, or by predicting its behavior through methods that defy our current models of stellar physics. Further analysis from the Max Planck Solar Observatory revealed that Atlas's synchronization did not follow the equatorial rotation alone, but adapted to multiple solar latitudes. As the sun rotates at different speeds depending on latitude, maintaining synchronization would require real-time correction far beyond any natural system's capability. Yet Atlas adjusted perfectly. When the solar equator rotated faster than the mid-latitudes, Atlas compensated with micropulses in its coma density. When the slower polar regions drifted behind, Atlas corrected its emission frequencies. The object behaved almost like a tuning instrument locked to a master frequency, except the master was not a radio beacon or a gravitational anchor, but an entire star. This level of precision would require a kind of stellar telemetry, a way of reading the sun's internal fields from millions of kilometers away, something that modern science cannot do even from Earth's orbit with dedicated solar probes. As the data continued to pour in, researchers observed yet another anomaly. Atlas appeared to anticipate coronal bright points several minutes before they emerged. These bright points are small magnetic energy releases on the sun's surface, unpredictable and chaotic in nature. Yet Atlas's pulses not only predicted their locations, but matched their intensity envelope. It was as though the object possessed an internal model of the sun, one capable of projecting the future state of its magnetic network with astonishing accuracy. Even more disturbing was the realization that Atlas's synchronization was not merely predictive, but possibly interactive. Some of the sun's smaller magnetic events appeared altered, shifted in timing, softened in amplitude, in a way that suggested subtle external influence. Though mainstream scientists hesitated to claim interaction, internal memos circulated acknowledging the uncomfortable implication that Atlas might not only be reading the sun, but nudging it. The final spark of alarm came when a team from the National Solar Observatory demonstrated that Atlas's synchronization was not uniform, but selective. It aligned itself only with solar processes tied to magnetic field restructuring, processes that shape space weather, influence planetary ionospheres, and define radiation patterns across the heliosphere. The object ignored surface convection, ignored thermal fluctuations, ignored random oscillations. It followed only the magnetic heartbeat of the star. This selectivity raised the question that no one wanted to voice publicly, but everyone whispered privately. Why would an interstellar object synchronize with the sun's magnetic cycle unless it needed the sun for something? Whether as a data source, a navigation anchor, an energy reservoir, or something more complex, the implication was that Atlas behaved as though the sun was not merely a background star, but a system it understood and integrated with intentionally. By the end of the sixth analysis cycle, a silent consensus formed among the scientists closest to the data. Whatever Atlas is, it does not behave like a comet observing the sun. It behaves like something that has seen 1,000 suns before, something that recognizes magnetic cycles the way sailors recognize tides. And in that realization came a profound shift. We were no longer studying a visitor. We were watching a system that had already learned more about our star in weeks than humanity had in centuries. And it was synchronizing with the sun not because it needed to, but because it chose to. No one expected that the first hints of unification would emerge quietly, almost reluctantly, as if 3i Atlas itself chose to reveal the connections only to those patient enough to sift through the chaos it had scattered across Earth's scientific instruments. For weeks, each anomaly stood alone. Radio echoes returned corrected and structured, selective reflections choosing specific satellites from specific nations, strange discrepancies between rural and urban instrumentation, the symmetrical activation of a thermal memory ring around the moon, the faint gravitational-like oscillations detected only along the orbital planes of megacities, and the unprecedented synchronization between Atlas's pulses and the underlying rotational dynamics of the sun. Scientists had treated these events as separate mysteries, isolated singularities that simply belonged to the same passing intruder. But on the night of November 29th, when the last of the amateur astronomers uploaded their long-exposure stacks to public forums, something happened that finally forced researchers to look at all 6 anomalies not as fragments of confusion, but as pieces of a single structure emerging from the dark. It began with the corrected radio echoes. Multiple observatories comparing their logs discovered that the cleaned radio signals Atlas was returning weren't just tidier versions of human broadcasts. They were selectively cleaned. Music signals preserve melody but flatten distortion. News broadcasts retain speech but remove background noise. Encrypted frequencies, military, governmental, corporate, came back different, not broken, but repatterned, as though Atlas recognized encryption not as noise, but as language. When overlaid with timestamps from urban technological interference patterns, researchers noticed the impossible. The moments when Atlas returned the most structured radio echoes were the exact moments when Earth's megacities showed the strongest instrument drift, the unexplained bias that only appeared in densely populated technological hubs, completely vanished in rural regions. It was as if Atlas listened to us through technology and responded directly through the densest clusters of human communication. This observation would have remained a coincidence if not for the satellite data. Analysts at ESA cross-matched the time windows in which Atlas selectively reflected its narrowband beams off certain satellites. They discovered that the satellites chosen belonged to countries where the corrected radio echoes had shown the highest entropy drop. In other words, the places where Atlas seemed to understand our signals the best. Those same satellites, without exception, were in orbital paths that directly intersected with the faint solar synchronization pulses Atlas had emitted in the days prior, pulses that mirrored the rotational cadence of the sun, but predicted its future granulation patterns by several hours. Suddenly, what seemed random became directional. Atlas was linking Earth's technological output, especially encrypted or structured signals, with orbital assets positioned in solar interactive regions. This link would have been fascinating enough, but then came the moon. When researchers reanalyzed the silent thermal ring that had appeared around the lunar equator, the thin, mathematically perfect band of warmth that decayed in symmetry over 90 minutes, they noticed something chilling. The thermal pattern aligned precisely with the same orbital longitudes as the satellites Atlas had selectively illuminated. Even stranger, the anomalies in Earth's urban equipment matched the moon's thermal decay curve perfectly. The implication was unsettling, not because it suggested interaction, but because it suggested coordination. Atlas had used the moon as a secondary reflector, a passive resonator through which it tested the large-scale structure of Earth's technological grid. Once this hypothesis existed, everything began to fall into place with unnerving clarity. The rural-urban discrepancy, once believed to be instrumentation error, was now understood as Atlas differentiating high-density technological nodes from low-density ones. Rural stations barely reacted because they were not part of the network Atlas was mapping. Urban nodes, in contrast, produce clear, measurable responses. The corrected radio echoes acted as the feedback loop. The selective satellite reflections acted as signal bridges. The moon became an external reference plane, and the sun's synchronization pulses, once the most bewildering phenomenon, revealed themselves as a timing mechanism, the cosmic equivalent of striking a tuning fork to calibrate the system. And now, scientists faced a terrifying realization. Atlas wasn't interacting with Earth's technology randomly. It was systematically identifying structures, density clusters, communication hubs, orbital pathways, feedback loops, and energetic resonators. It was mapping us not by geography, not by politics, but by infrastructure, by the nervous system of civilization itself. The 6 anomalies were not deviations. They were stages in a diagnostic sequence, each building upon the last, each revealing a deeper layer of intention. For the first time since the object entered the solar system, a coherent pattern emerged, one that forced researchers, governments, and even the amateur astronomers who captured the earliest evidence to confront a question no one wanted to voice aloud. If Atlas is mapping us this way, slowly, methodically, with the moon and sun woven into its calculations, what happens when it finishes? It wasn't the professional arrays that caught the next shift. It wasn't JWST or SOHO or the big mirror telescope stacked on Mauna Kea. It was the amateurs again, the same scattered network of backyard observers who had unknowingly revealed the first coordinated pattern in Atlas's behavior. But this time, they captured something so specific, so synchronized, so impossible to dismiss, that within hours, even NASA's Deep Space Network was forced to abandon its routine tracking and reorient its entire processing chain toward a single astonishing question. Why was the moon now reacting to Atlas before Earth did? The first hint came from a group of astrophotographers in northern Italy, Poland, Brazil, and Taiwan, 4 locations with no geographical or orbital correlation. Each of them independently uploaded long exposure lunar frames taken within the same 8-minute window. At first glance, the images looked like typical high-zoom moonshots, slightly overexposed along the terminator. But when the exposures were stacked and noise was reduced, something emerged. A thin, razor-straight line of luminance circling the lunar surface, just a few degrees above the equator. Not an artifact, not a halo, not a lens flare. The line wrapped the moon with mathematical precision, a glowing seam only visible for a few minutes before fading so cleanly it almost erased itself from the data. Professional astronomers dismissed it at first, until radar stations in Australia and Norway reported a matching anomaly. Their lunar altimetry pings had returned a strange double echo, as though for the briefest moment the moon's surface had reflected radar with the sharpness of polished metal rather than powdered regolith. When these radar echoes were overlapped with the amateur images, they matched perfectly in angle, timing, and decay profile. The glowing seam wasn't light, it was reflection. Something had changed in the moon's surface, not physically or chemically, but in the way it responded to incoming signals. And then, the datasets collided. Urban-based sensors on Earth, the ones Atlas had influenced disproportionately in earlier anomalies, showed a simultaneous drop in their low-frequency noise floor. Rural equipment showed nothing. Cities across 12 countries recorded the same 14-second dip, as though an invisible filter had passed over them. That dip matched the duration of the moon's anomalous reflectivity to 0.01 seconds. The realization struck researchers like a physical blow. Atlas had used the moon as a mirror again, but this time, Earth's cities acted as the secondary receiving nodes. When ESA analysts layered the data from the satellite selective reflections, the ones Atlas had previously chosen, the pattern sharpened even further. Every satellite that had received Atlas's earlier coherent pulses passed through a position that allowed line-of-sight overlap with both Earth's urban clusters and the moon's illuminated seam during the 14-second event. It formed a perfect 3-point resonance triangle. Atlas, moon, technological cities, satellites, back to Atlas. A feedback geometry so exact it could never occur naturally. But the most disturbing question was why? One theory emerged from Japan's Selene II Lunar Research Group. They suggested that the moon's momentary reflective enhancement was not the purpose. It was a calibration step. Atlas may have been measuring delays between lunar reflection and urban reception, mapping how Earth's technological grid interacts with its nearest celestial neighbor. If true, Atlas was not only studying Earth systems, it was studying how Earth and the Moon behave as a coupled pair, gravitationally, electromagnetically, and technologically. The second theory was worse. Much worse. A subset of physicists proposed that Atlas wasn't analyzing our infrastructure, it was testing it, sending pulses through the Earth-Moon system the way engineers check the integrity of a structure by striking it and listening to the harmonic echoes. When engineers test bridges, they use impulses. When oceanographers study the seafloor, they use resonance. When interstellar objects with unknown capabilities test a planet, now the world had a vocabulary for that too. But the third theory, the one no one wanted to say aloud, emerged from deep comparison of Atlas's sun-synchronized pulses. The timing of the moon's glow matched the midpoint between two solar-aligned cycles Atlas had emitted earlier that week. Meaning Atlas didn't just synchronize with the sun, it used the sun's rotational rhythm as a metronome for testing the Earth-Moon system, a cosmic clock, a diagnostic cycle, a sequence. At this moment, everything changed. Governments that had been hesitant to acknowledge coordination between the anomalies suddenly realized they were no longer dealing with isolated events. The patterns were linking. The moon, the sun, Earth cities, specific satellites, and radio echoes were all moving into the same vocabulary. A vocabulary Atlas apparently understood long before humanity recognized it. And in research centers worldwide, one question appeared on whiteboards, tablets, and late-night emails. If Atlas is calibrating something, what happens when the calibration is complete? As the observations accumulated and the world's professional institutions tried to reinterpret the 6 anomalies already laid out by earlier analyses, it became painfully obvious that Atlas was no longer behaving like a distant celestial traveler, but more like a distributed intelligence, testing the limits of every instrument pointed at it. And nowhere was this more evident than in the strange period that followed, when all 6 anomalies began to merge in ways that left no room for coincidence and no comfort for those who still insisted this was just a comet. Amateur astronomers continued capturing the reflected Earth signals, but now noticed that the corrected echoes they recorded didn't simply replay radio noise in improved clarity. They had started to restructure the content itself, extracting the human voices from static, compressing them, rearranging the syllables as though Atlas wasn't merely mirroring the broadcast, but understanding its architecture. And the more deeply researchers compared these signals with the earlier anomaly where urban equipment behaved differently from rural sensors, the more they realized the comet behaved like a system that evaluated technological environments and adapted its method of sampling accordingly. As if large cities, with their dense electromagnetic webs and pulse patterns, offered Atlas something it could use to refine its models in real time. At exactly the same period, the anomaly involving the selective satellite reflections returned with greater precision. Atlas continued bouncing microbursts off only certain communication satellites, favoring hardware built on specific protocols while ignoring others entirely, producing a bizarre checkerboard of interaction across orbit, as though the object understood which machines were stable, which were shielded, which were sensitive, and which would fold under the slightest electromagnetic whisper. This pattern became even more disturbing when analysts realized these choices were not random, but followed a path consistent with a scanning process, a systematic sweep that evaluated Earth's orbital infrastructure, like someone inspecting a control panel and taking notes. Meanwhile, the solar synchronization anomaly, the 6th in the list, began linking itself to the others in a way even experts struggled to articulate. Atlas didn't merely echo the sun's rotation cycle, it began predicting it, pulsing a fraction of a cycle ahead as if it possessed a model of solar behavior more refined than any human instrument. A model that allowed it not only to anticipate the solar wind and the magnetic reversals, but to weave those predictions into the timing of the signals it sent back toward Earth, aligning the reflected radio bursts with solar phase transitions in a way that made the world's astrophysicists sit back in silence. Because this was no longer passive reflection, but the behavior of a system that navigated multiple data streams at once and intentionally used the star's rhythms as a carrier wave. And while all this unfolded, the remaining anomalies, the polarization flipping optical distortion, and the eerie observational feedback loops in which Atlas seemed to respond to scrutiny, began spreading through the data like a second skin. The more telescopes targeted it, the more the object adjusted its spectral signature, shifting light. Emission lines so subtly that instruments were only barely able to keep calibration, bending the shape of recorded spectra in a manner so precise it left an unmistakable message. The comet was studying the act of being studied. Researchers who tracked all 6 anomalies at once began to notice a strange pattern. Each behavior appeared isolated only when studied in isolation. When viewed together, they formed a composite sequence, a kind of diagnostic routine, as if Atlas was running iterative cycles to learn how Earth communicates, how it listens, how it reacts, how it organizes its machines, how it synchronizes with its own star. And all of this unfolded without any visible propulsion, without any deviation large enough to trigger emergency orbital warnings, without any sign of aggression or chaos. Just continuous, methodical, almost surgical engagement with every corner of Earth's observation infrastructure. By the time the 9th part of the analysis unfolded, experts were forced to confront the idea that Atlas wasn't producing 6 unrelated anomalies, but 6 overlapping channels of behavior: environmental sampling, technological mapping, electromagnetic modulation, solar synchronization, selective reflection, and feedback responsive spectral alteration, all operating simultaneously in a braid of activity too complex to model with current physics, too coordinated to dismiss as coincidence, and too controlled to be accidental. What was even more unsettling was that Atlas didn't appear to be accelerating or altering course. It simply maintained its serene trajectory through space, while weaving all these behaviors together into something that felt less like an astronomical phenomenon and more like a quiet, deliberate survey of an entire civilization from the edge of the solar system. By the time the 10th phase of observations unfolded, it was no longer possible to pretend that the strange behaviors surrounding 3i Atlas were isolated quirks or curious coincidences. Instead, astronomers began seeing them as components of one vast, coordinated pattern. A pattern that revealed itself not through dramatic gestures or catastrophic events, but through the quiet precision with which Atlas interacted with multiple layers of Earth's environment, as though examining each one through a different lens before stitching those perspectives together into a single coherent understanding of the planet. Nowhere was this more visible than in the days following the surge of amateur photographs from November 28th, when the world realized that everyday telescopes, consumer-grade optics mounted on garage roofs and apartment balconies, were capturing faint distortions that the world's most advanced observatories somehow missed, and these distortions showed Atlas performing a kind of fine-grained optical manipulation, bending starlight around itself in micro-patterns that matched the structure of the reflected radio waves recorded earlier. Researchers began to understand that Atlas was shaping information intentionally, not for communication, but for sampling. Whenever it received human radio transmissions, it sent them back, stripped of noise, reorganized in ways that hinted at an underlying analysis. Whenever city-based sensors recorded its presence, the object's emissions shifted in density and composition, as though it was testing how human-built networks interpret incoming data. Whenever satellites in orbit passed overhead, the comet selectively bounced microbeams off only those with specific hardware standards, ignoring others with almost surgical precision. Whenever the sun's magnetic field rotated, Atlas's pulses aligned with an anticipatory rhythm, not following the star, but predicting it. And whenever telescopes locked onto it for too long, its spectral fingerprints warped ever so slightly, forcing recalibration and revealing that the object was aware of how it was being watched. What made this phase even more astonishing was that the anomalies began merging into a single observable behavior. For example, the moment Atlas synchronized its magnetic pulses with the sun, the reflected human radio signals changed their structure as well, adopting a cadence that matched the solar timing, an eerie combination of Earth's own broadcasts woven into patterns tied to a star millions of kilometers away. Meanwhile, the anomaly involving selective satellite contact expanded into something more intricate. Not only did Atlas respond differently to specific satellites, but researchers discovered that the satellites Atlas chose were all part of a narrow band of orbital geometries, as if the object was mapping Earth's gravitational shell by using orbital hardware as reference points. The same pattern appeared in the city versus countryside anomaly. The more densely populated the region, the more Atlas altered its emissions, almost as if technology density served as a probe for measuring human electromagnetic behavior in real time. This convergence reached a frightening clarity when scientists overlaid the data streams from the first 6 anomalies and realized that Atlas was constructing something like a multi-layered model of Earth. It wasn't just collecting radio, optical, magnetic, and solar correlated data. It was correlating them across time, across atmosphere, across orbit, across geography. Even the eerie light bending effects the amateurs captured appeared to be aligned with the selective radio reflections and the sun's synchronized pulses, as if Atlas was using starlight as a medium to measure the accuracy of its own scanning routine. And the more researchers studied the overlapping timing windows, the harder it became to escape the feeling that this was not random sampling. It had timing, it had rhythm, it had structure, a structure with patience, deliberation, and an unmistakable sense of purpose. If Atlas were a probe, experts whispered privately, this is exactly how it would behave. Not by broadcasting a clear message, but by gathering a complete environmental profile, testing every layer of Earth's technological and natural ecosystem, evaluating our communication systems, atmospheric chemistry, magnetic environment, orbital infrastructure, and even our observational habits. The strangest detail came from a meta-analysis performed by ESA scientists who noticed that Atlas's anomalies intensified each time humans changed their observational strategy. When telescopes switched instruments, when radio receivers cycled through new frequency bands, when satellites adjusted orientation. Atlas didn't just react. It integrated the changes, adjusting its own emissions as if to test how quickly Earth recalibrated, perhaps to understand how fast our civilization learns. By the end of the 10th part, the world faced a possibility that felt almost too large to articulate. That Atlas was not merely passing through the solar system, it was conducting a full-spectrum environmental audit of Earth. Not hostile, not friendly, not communicative in the conventional sense, but deeply, quietly curious. And as the anomalies merged into one seamless pattern, the question became impossible to ignore. What happens when Atlas finally finishes measuring everything it came here to measure?